All right, good afternoon, everyone. I'd like to thank you all for coming. I'd like to welcome you to Design Approaches for Security Automation here in Lagoon Cay. Speaking with us today is Peleus Uhley. He's the lead security strategist at Adobe. A couple of brief notes. If you would, stop by the business hall located in Bayside AB, and we have the welcome reception there tonight at 5:30 to 7. Black Hat Arsenal is on in the Palm Foyer on level 3, and you can join us for the Pony Awards over in Mandalay B, C, and D at 6:30. I'd ask you all to put your phones on vibrate, and welcome Peleus.
Thanks for everyone coming out. So let's go ahead and just jump right in. So what I'm going to cover in this talk is design approaches for security automation. I'm not going to be releasing code with this talk. Most security automation, if done well, is integrated with your specific company and it's got custom tweaks. You'll play with open source software for a while and then you'll hit the limits of what it can provide and you'll start to do custom tweaks. And so some of what I'm going to talk about here is I'm going to assume you're ready to start doing custom tweaks and what are the things and the questions you need to ask in order to be able to do that. And I'll sort of walk you through the process that we went through and the questions that came up during our process of designing our own security automation framework. But before I get into that, what I'm going to talk about is some of the high-level stuff and some of the smaller projects you can do along the way, which aren't as big as building a full security automation framework for yourself, building a full Chimera or Twitter SADB or something like that. What are the sort of smaller projects that you can do which give you a high ROI but aren't as complicated to implement? So when you start any project, the first thing you want to do is you want to have a clear idea of why you're doing it and what you want to get out of it. A lot of times you come to talks like this and somebody does a talk on a big security automation framework and it sounds great. And you kind of want to go do that big project, but you want to have a clear idea of what you're doing, right? So the slogan on the internet, the meme on the internet is automate all of the things. And automation is what computer science has been doing since the very beginning, right? A vending machine is technically automation. So what's the difference? What's the difference in what you're going to design? If you go downstairs to the vendor booths, people have been doing large-scale security automation before, and they called them enterprise editions. But you just take a tool and then you scale it to run across your entire enterprise, and it's the enterprise edition. But if you've ever used the enterprise edition of something, you probably had sort of middling success. It worked, kind of worked, but you didn't necessarily get the data out of it you wanted it in terms of metrics, or it didn't scale the way you hoped, right? And so you want to think about those sort of things when you're thinking about building security automation for yourself, because you don't want to just reproduce an enterprise edition of a piece of software. You want to have something that's really going to be able to move your team forward. And so you want to think about these things because any idea can be automated, even bad ones. So, when people come to these talks and they listen, they get very excited about what they can do as an engineer to build a large-scale security automation framework. And so, you start thinking about it, and it's like, oh, we can use the cloud, and we'll have all this scalability, and I've got this great idea for it, and I can use all these JavaScript frameworks for the UI, and we can get all of this great stuff out of it. And it'll take me 6 months to a year to build, but it'll be awesome, right? Because we'll have this really robust security automation framework. But as I said, I've been in the industry for about 15 years, and I'm sort of becoming the old curmudgeon in the room. And if you're an old curmudgeon, you sort of go, okay, that's all cool, but can we just do that with cron tab? Right? Cron tab allows you to automate things. It'll run things on a schedule. You can put Python scripts into it. You can get data out of it. It's far less complicated than going and building a scalable architecture in Amazon. And the time investment's far lower. So how's what you're doing any different than what you could already do with cron and some fancy Python scripts? And the other thing that goes through an older engineer's mind is the young engineer has the idea for this great tool, and so you've got Mallory here who's an engineer, and she's your best programmer, and she can design a really awesome engineering automation framework, and it'll be big and robust, and it'll run like a Swiss watch. And you believe it, right? She's one of your best programmers. She can do this. But the old engineer is thinking about what's going to be down the road, right? Because the old engineer is seeing this in 5 years, right? Because even though it started out as a Swiss watch, those really good developers often get pulled off into other projects. And so then it gets handed off to somebody else who doesn't quite understand it. And then no one thought about the operational aspect of it. Who's going to be on pager duty for when this thing goes down? Who's going to make sure the OS is updated and apply the patch for the thing that's running this environment? It's all the overhead of not just building the tool, but keeping it running as well. And you have to sort of think about those things, because otherwise you'll build something, it'll be fancy and cool, and it'll kind of work for a while until people lose focus, and then you sort of end up with this, right? And if you're working in a large organization, you probably have a couple of projects which are currently in this state. So if you're going to do this project, you want to think about why you're doing it, to make sure that if you're going to do the investment to get that operational payoff, that you get what you want out of it. And when you do security automation, you can be doing it for different reasons. You can do it for consistency. You're automating something so it happens the exact same way every single time. And then you can rely on your network because there are fewer special snowflakes. You can be doing it for scalability, which is what a lot of people look at today because the cloud has made scalability an easier thing to do. You can be doing it for efficiency. You just need things to be able to go faster, and you want to be able to do more things with fewer resources. And you also may be doing it for metrics. Maybe you're fingerprinting your organization. Maybe you're trying to get out of this tool metrics that you'll be able to use to drive better business decisions. And these are all valid reasons. Some tools cover more than one of these. But these are the types of qualities that you're looking for in a security automation framework. And when it comes to metrics, one of the things that you have to keep in mind is that arithmetic is not the same thing as valuable statistics. In the industry, a lot of times, in life in general, we see people confusing arithmetic for meaningful metrics. And just because you can count something doesn't mean that data is necessarily reliable. And also, bigger numbers are not necessarily what they may first appear. So, like for instance, let's you do a web app pen test, and you have 50 reflected cross-site scripting bugs, and you've got 5 XXE injections, right? 50 is the bigger number. It's the more, you ran it at scale, and you got a bigger number, and so that appears to be the bigger problem because there's more of those. But depending on your environment, those 5 XXEs, which can give you command line injection on the OS, may be the thing you're actually more concerned about, even though the number is smaller. Right, so that's one of the things that you have to look out for when you're going to build a security automation framework. So you need to be able to add meaning and context around these things, because if you're just looking at numbers, you may miss the bigger picture. So you want to be able to think about those things. And another way that the data affects management positions affects management decisions is how it's going to guide the team. So one way that people do security automation frameworks is they go and they take a web app pen test tool and they just decide they're going to run it at scale. We've got Zap, OWASP Zap proxy, and we're just going to run that at scale. Or we've got Burp, and we're going to run it at scale. And this will work. You'll be able to scan across the entire environment. You'll run into some scalability issues, and that a lot of these tools need to be configured for each thing that you're running against. Otherwise, you get lots of false positives. And if you get lots of false positives, then your data is not going to be as good, because you're going to be making guesstimates about how many of those things are false positives, unless you're able to scale the human side to match what you're doing on the computer side, to have somebody go through all of that. And if you don't, you're just creating noise at scale. And creating noise at scale doesn't help the organization. But it is a valid way in some instances. The approach Adobe took and the way that we looked at it sort of came out of looking at behavior-driven development. And so rather than taking a big tool and trying to run it at scale, we took a look at what are very simple questions that we can ask that have a definitive true-false answer and that will give us reliable metrics about things that we want to be able to improve. So for instance, you might take SSL configurations, right? Everybody's trying to phase out SSL v3. Determining whether or not your web servers run SSL v3 is a simple yes, no answer. There's no interpretation. You try to make an SSL v3 connection, it works, it doesn't, you get a true false answer. And then that allows you to get a reliable metric on your SSL configurations, because it's true false, there's no debating it. It is a smaller question to ask, but it's maybe an important one for your organization if you're trying to phase that out. And those questions can be important because it guides the team on what that you're trying to do. The metrics that come out of this tool, the team will see as what they're being measured against. So if you take a web app penetration testing tool and you run that at scale to find XSS bugs, and the output of the tool is XSS, a list of XSS bugs, then the team's going to see that they've got a bunch of bugs to fix, and so they're going to focus on bug fixing. But if you're trying to go after XSS, there's other measurements you could do which might lead the team to a different conclusion about how they try to address XSS. So they might, you might want to measure like how many teams have deployed content security policy headers, right? And you could run that as a metric at scale and get numbers back. And if the teams think that they're being measured against whether or not they have content security policies deployed, they're going to go after solving cross-site scripting in a different way. They'll focus on a long-term mitigation approach, and they'll focus on deploying that rather than whack-a-moling each individual bug that you can produce. And depending on your organization, you may need both. It depends on where you guys are with regards to security and what your priorities are, and whether you have the time to do the long-term investment in content security policies, or maybe you're starting to become a target of attack, so you just want to do a bunch of bug cleanup and you just need to find everything you can as fast as you can. So you need to be able to consider those things, because how you do that, how you approach it will affect teams and how they perceive problems, and it'll affect how management sees the problems as well, because you're going to be measuring, you're going to come up with metrics that people are going to use to make decisions. But when it comes to automation, you don't necessarily have to start with building a large security automation framework. If you look at your developer environments, they've already got a lot of automation frameworks in there. You're using things like Git and Jenkins and Maven and Chef. And a lot of these tools, in fact, I think all these tools, you're able to modify to be able to get them to perform the security tasks. And there's a real advantage in this. One of the advantages being that somebody else is already on pager duty for this. Somebody else is already on the hook for maintaining these environments. And so if you just create a module for it, you're only responsible for making sure the module keeps up, and you're only responsible for the security aspect of the code and what it's trying to test. You're not on the hook for making sure that Git keeps running, because your development teams already have operations teams that are doing that. And so there's a lot of advantages to doing this. The other advantage is if you go to a development team and you've got this brand new 50,000 line tool that you built and you're trying to get it into their build environments, which they rely on, you're going to get a lot of pushback because they don't know what the tool is, they don't know where the tool came from, they don't know how much testing's gone into this tool. They're going to be concerned about what happens when it goes down. Is it going to break their build environments? Things like that. Whereas if you look at integrating into the tools that they've already got, the discussion becomes much shorter because they already understand the automation framework and they understand what it does. And you just have to explain to them how you're modifying it. And you just have to be able to sell them on the small modification. And what this allows you to do is you get a lot, I talked about the different properties of security automation that you can go for. This allows you to go for consistency. Like integrating into these things isn't necessarily a scalability project, but it is a consistency project, right? If you add a chef's recipe into your chef builds for making sure that the OSs are configured to your standards, right? That ensures you have consistency in your environments. And so that's a great way to do smaller projects, because making the modifications to these are smaller, and not necessarily sign up for maintaining a huge external framework where you're maintaining the code and the OS and everything that goes with it. And there's lots of ideas if you look around the web for people who do this. There is static analysis that gets integrated into the build process. Netflix releases a lot of tools. They just released a tool called Bless, which manages SSH keys using Lambda. There's a lot of things in there that people use. If you're putting, you can integrate into the AMI version tracking so you can keep track of what's been pushed to your environments. We've done a couple of things to automate things that people may not think about. So Adobe has a security project, a security training project where you go through security training, and the first two levels is true-false tests, and then or multiple choice tests, your normal exam training, and then once you get past that, it's based on what you do for the company. You have to actually do security work to show that you can apply the knowledge in the company. And so the developers and the QEs will do side projects. They do enough of the side projects, they up level in the training, and they get a new belt. And so one of the projects that someone on the development team did is they just did a Git review checker. So like a lot of compliance requires that when you check in code that somebody peer reviewed it before it got checked in. And you need to be able to enforce that nothing gets checked into your code base that hasn't been peer reviewed by somebody else. And so for his brown belt project, he wrote Jenkins module, which checks to make sure that the person who did the pull request in Git is not the same person who did the commit in Git. And then that just automates that simple policy check and makes enforcing that rule a lot easier than maintaining a bunch of documentation, stuff like that. So, and because he did it as a brown belt project, that means that team wrote it, which is even better when it comes to maintenance because the team's actually maintaining it as opposed to the central security team. And we also do a lot of things with third-party library tracking in Adobe. So if you look at the build tools they're using, so let's say they're using Maven. Maven has the ability to dump all the Java libraries that you're using in the project along with their versions. And so that can be really useful information if you're trying to track CVEs and vulnerable libraries and you're trying to track things like Java deserialization bugs that come along. You need to figure out who's using which libraries. And so, Maven already has the ability to dump that information. It's only a small amount of work to upload that to a central location. You get a bunch of teams to upload that into a central location. Now you have something you can go grep against. And that's only a small amount of code. And then you can continue to build on that. So like if you get a risk feed or a vulnerability feed from someone like risk-based security, you can then do diffs on that and have people get email alerts the second something matches something in the risk-based security list. And you can sort of automate keeping track of all of your third-party libraries in your code, which is a huge problem that a lot of companies have. And if you look at the development tools, you may be able to pull those things out. And so that's pretty much what Adobe did, is we eventually built it up to create a UI for it where people can go in, they can see what vulnerable libraries are potentially affected that they have right now. They can put comments next to things to say like, yeah, but we're not using that portion of the library, so we're okay. And we have a third-party library tracker. And whenever you do these sort of things, they have they're nice because if you've ever had to go through like SMART training where you have SMART goals for your career, like these projects fall under the SMART guidelines, right? They're very specific, they're very measurable in what they can do. They're relevant to the team, they're integrated into what they're already doing, and it's a time-bound project. It's not going to be one of those projects that scope creeps itself into infinity. So that's one of the things you can do. Another thing you can do is you want to have a picture of your network. If you're going to scan your entire company, then you need to know what your entire company is. And if you're in a small startup, that's maybe not hard because the sysadmin sits next to you and you can just tap them on the shoulder. If you work for a large company and it's much that's made up of several groups and you've got acquisitions and stuff like that, having a picture of your company is a much bigger task. And so, like, I've been working on a side project at Adobe, which I've called Marinus. Marinus was one of the founders of geography. And also, there's a satire called Satyrus Marinus, which is a combination of a goat, a man, and a fish. And when I was putting all these data sets together to try to get a picture of the company, it felt like it was making as much sense as putting together a goat, a man, and a fish. I can't go with man, bear, pig, because South Park already had that. But when you're up at 3 in the morning and you're staring at the data, that's sort of the face that you end up with when you're trying to make sense of it all. But I took the approach that, like Bill Gates says, right? If you have a hard job, give it to a lazy person because they'll find an easy way to do it. And so my secret, and you guys are all black hat people, so I'm sure you'll be good with secrets, is that there are people out there on the internet that are already scanning your networks. It's true, they are. They're scanning your networks. And they will post that information online. So rather than going and building an automation tool myself, I was like, oh, well, these people already did it for me. I'll just download what they've done, right? And that was a smaller step towards large-scale security automation because I can go pull from all these different sources. And there's stuff that Rapid7 does through Sonar project. There's scans.io, which became census.io. And there's a little bit of a challenge in using these things because they're very large data sets. Like some of them are 700 gigs in size, and so you got to write Python scripts which can parse through all these things without loading the entire file into memory and crashing the machine. But it's actually not that hard. You just use Python's with statement. But Adobe's also a large organization with tons of domains and stuff. So what ends up happening is you crawl it. If you do go with the Python script approach, you're going to write like 50-line Python script that takes 5 days to run as it goes through all this information. But if you don't care like how quickly you get the information, it's not a big deal. You write 50 lines of Python, you go away, you come back, and you take a look at it. And you can uncover a lot of stuff about your network from this. Some of it you'll uncover is you'll find out-of-date information. So you'll find like DNS entries, which are pointing off into space because someone forgot to delete the record. You'll find your own documentation that's out of date. But it's good for other things as well. For instance, if you're doing red teaming within your organization, this is all information you can collect about an organization without ever actually sending a packet there, right? And so that can be useful. And if you work in an organization where they're really sensitive about you scanning the production network because if you send a single packet to it, it might fall over. Well, you didn't scan it. Somebody else did. So it wasn't me. I didn't scan it, but you still take advantage of that information. So I know some companies, like they use the certificate transparency logs to monitor anytime a new SSL certificate pops up so they can make sure that they know about it and they can go find out when people are going off and doing side projects without telling them. But let's say you want to go for the large automation framework. Let's say you want to, you've done those small projects, you've done like the little side things, but you want to be able to build an automation project for within your own organization. What are the design things that you can look at? You will probably go through the build versus buy cycle of debate. And I cannot give you the answer to this because it all depends on where you guys are in your life cycle. You'll build something and then it'll become hard to maintain. So you'll buy something until you get frustrated with the vendor. And then you'll give it to an intern to go build and they'll build it and that'll work until you realize it's intern code. And then you'll go back to buying it from a vendor. If you're the old curmudgeon like me, then you've been through this cycle a couple of times. You've done a couple of laps around this. So that's whether you build or buy is up to you. But if you are going to build, there's plenty of places to go and steal ideas from. There's baseline security automation frameworks already out there. For instance, Gauntlet is one of the ones that came from BehaviorDriven Development. That's a good one to take a look at. And it uses the security assertion thing that I've talked about. Mozilla has a project called Minion. There are talks about Salesforce and their Chimera project, Twitter SADB. They haven't open sourced their code in these projects, but they do talk about the pains of going through them. And it's a good place to go and start mentally prepping yourself for tackling this. And there's also tool consolidators. If you don't have the ability to build, there's projects like ThreadFix where there's a commercial version and an open source version. And it allows you just to aggregate all the data that you have from your existing tools. So you want to do a little bit of research into that. And you want to take a look at the tools that you plan to deploy and how they're going to actually work in an automated environment. So for instance, Zap or some web application proxies listen on a port, and the way that you drive them is you communicate to them over that port. But the problem is with anything that listens on a port is that only one thing can be on that port at a time, so you only have one of them running at a time. So either you deploy multiple hosts, each of which has one of these tools, or you try to figure out some way to launch a bunch of instances of the tool listing on different ports. So that may be a problem, and that may drive you towards something that's command line. And you also want to take a look at, does it allow you to run individual tests, or do you have to run the entire suite? Some of the tools, give you granularity in terms of what, running it down to an individual test and only that test. Some tools only allow you to run groups of tests, and that may be more than what you want. But you want to take a look at it. You want to look at the tool prerequisites. And you want to keep in mind REST API challenges, because most of those tools are based on crawling the website. If you have REST APIs, there's nothing to crawl. And there's a couple of ideas out there for solving this problem that have been discussed. For instance, some people will grab the access log from a production system, and they'll just take all those GET requests as the baseline of traffic to that REST API. That works if you have post and put. It doesn't work as well because those variables don't get caught in the logs. But you can work around that if you pull logs from a staging environment. Other people will take the QE testing frameworks that already exist, and they will just have those QE testing frameworks that the QE team is using to test the site, and they will proxy that through the web application penetration tool, where it just acts as a man in the middle and records all the traffic back and forth, and then you get your baseline that way. But you want to think through those types of problems as well, because otherwise there'll be gaps in your data if you don't take into account REST APIs. And then also with any sort of web app penetration testing environments, you got to be able to plan for dynamic variables, right? How is it going to know what the list of targets are? Are you defining the list of targets by IPs, by domains, by URLs? Are you going to be able to need to share those lists so that different people can work from the same list of hosts? Also, who's going to have access to those lists, because you don't necessarily want everybody in your company to be able to scan the entire company. You want to make sure that you control who's scanning and where they're going. And I can't overemphasize having a clear plan before you start coding. So I worked with Mohit Kalra and Vijay Sahu and Mayank and Kriti, and a group of people. And Mohit and I spent months sort of designing and talking about how this thing was actually going to work before we even started putting a developer on coding it, to make sure that we had thought through all the challenges that come along with it, like how we're going to onboard people into this environment, what sort of authentication and authorization we needed, where are we going to scan from? Are we going to scan from the internal network, or are we going to scan from the external network? And how are we going to support that? Because there are advantages to both. If you need to test stuff that hasn't gone live yet, you need to be able to scan from the internal network. If you want to understand what your organization looks like to attackers, you need to be able to scan from the external network. So you need to be able to deploy your tools in different areas to be able to do that. What do we want to do with regards to reporting? Like, how's this information going to be consumed? Is the data going to be useful? What's the best measurements? And one of the things that happened consistently throughout the process is we always went back and asked ourselves, and why aren't we doing this with cron? Because if you keep asking yourself that question, it will keep you focused on what the value is. It'll sort of help you get rid of scope creep in your ideas and keep you focused on what it is that you wanted to be able to do. And so, some of the key things that we wanted our framework to be able to do is we did not want the framework to be the tool. We didn't want to be strongly bound to the tool itself. We also didn't want it to be the reporting from it. So we made a conscious decision to separate the tools from the core engine. That way we could easily rotate tools in and out, depending on what we needed. And then we would also avoid sort of the language and dependency conflicts from having things on that arise when you try to use multiple tools, right? Because if you're using Zap or Burk, they need Java, but then you may have some custom tools, and this developer in your org is writing in Python 2, but this other developer has already gone over to Python 3. One guy's using URL-lib, another guy's using requests. You run into a lot of conflicts. And so one of the ways that we solve that is that all the tools go onto a Docker image, and you don't provide us with the tool that you need to run, you provide us with a Docker image that you need to be able to run. And that allows us to abstract ourselves from dealing with all the dependencies that your tool may need and any conflicts that may arise from that. It did take more work because you have to build APIs in order to be able to do this. So you have to have a way for the Docker image to talk to your queuing system to let it know it started, to let it know it finished, to be able to send the reports back. And you have to spend some time designing those APIs, which is a bigger investment in the short term, but it also abstracted us from a lot of the operational stuff that would come down from that. And when you're talking about like whether or not you're going to run on Docker, platform choices come up. Like a lot of security automation tools get deeply integrated into AWS because that's where a lot of people are. But the industry is starting to move towards multi-cloud, or you acquire a company that's in a different cloud. And so do you want to be using AWS's queuing system, or do you want to use your own queuing system? How strongly bound do you want to the environment that you're hosting in? And you also have to take into account things like geolocation. You may need to scan from a network that's relatively close to where that thing is, as opposed to scanning from all the way across the Atlantic or all the way across the Pacific. So you want to take into account those sort of things, like where are we going to deploy it, how tightly bound do we want to be to that deployment platform, and will allow us to move around the way that we want. And the other thing you need to be able to do that we decided on is we really wanted to separate data reporting and dashboarding from the core tool itself. Because one of the things that happens is everybody wants the data in their own special format, right? Because different people want to look at different aspects of the data. And if you try to make the tool the dashboard, then you become the UI jockey for the tool. And so you keep having to change it because, I don't know, this fall there's a different pattern of colors for pie charts than there was in the spring. And so you need to upgrade to the latest colors for pie charts, or whatever requirements that people have. And so if you sort of separate that out and you provide APIs, then people can go pull the data however they want. They can present the data however they want. And you don't necessarily have to worry about the data representation. You just need to worry about the data accuracy and the tooling for it. And then you need to add some authorization checks just to make sure that the right people can pull that data. But we made a conscious decision not to be the dashboard provider. We have a basic dashboard that says, yes, your tool completed. Here's the basic set of the results, but we're not going to do any other dashboarding beyond that. We're just going to give you an API and you can go pull it however you want. And in terms of the overall design, this isn't actually the security automation framework. This is a tool currently called WhatWeber, which was designed by Mohit Kalra on my team. who's here if you have questions about him, about this. But he designed it using all the principles that we talked about in designing our large-scale security automation framework. And this design was actually easier to show in the slide than the full SAF, but it has all the properties. So what he wanted to be able to do is run a tool called WhatWeb to be able to fingerprint websites. And he wanted to be able to do it in a scalable manner. And so you can see that you need, he separated out the UI layer from the scalable API layer, from the queuing system, from the workers, and the storage. And you end up with a sort of separation between all these different levels. And he has workers for running the tools, and he has workers for getting the results data back. Because if you're running things at scale, sometimes the results that you get back are going to be large, and so you might need workers or something like that to manage pulling the results back. And this has all the properties I've discussed thus far in the talk with regards to how we design things. And he did everything on Docker because he was Docker allows you to do things on your Mac, so you can work on the train. But it also allowed it to be scalable for when he wants to take it to the next stage. And having the separation and using Docker and having the workers separated out allows him a lot of flexibility. And so if he wanted to switch out the WhatWeb tool for any other tool and run that at scale, it has the same properties. In terms of the code that went into it, he used a number of different technologies. He decided to go with Python for his environment. And so you have a bunch of web technologies on the front end, everything from WebSockets to JavaScript frameworks to HTML for the GUI for it. He went off of Nginx for his tool. And then you start using things like Celery and RabbitMQ for the queuing systems. And so what tools you use, the individual tools that you use to build your environment are not necessarily as important. The most important thing when it comes to tools is to use the tools that your developers know, which is the problem that you run into a lot of times when you adopt web application open source tools. Is it's written in Ruby, but you're a Python shop and you kind of muddle along with it until somebody finally provides a Python tool, and then you switch over to the Python tool because you understand it, you know how to maintain it. But this gives you sort of an idea of how we tend to structure those, how we went about conceptually constructing these types of tools within our environments. And you can use other tooling systems depending on what you want to be able to use. You could use, if you want to use SQS for your queuing system, you can. But this is sort of the design that you're going for. So to sort of recap what we had in the security automation framework, it was security assertion based. We ask small questions so that we can get specific answers, and then we can work on slowly raising the company. It takes a little bit more work because you're creating a test for each question, but the data is far more accurate because it's a true-false. It's not like blind SQL injection where you don't really know whether it's there or not until somebody does human analysis. We didn't want to be able to generate noise at scale. We instead focused on security assertions. You definitely want to have loose coupling for this. We keep the tools in separate workers because we want to be able to deploy the tools internally. We want to be able to deploy the tools externally. We want to be able to deploy them in geographically different locations. So having those tools, whether it's a Docker image, you can do it with AMIs as well, but having them in portable environments allows you to deploy them wherever they need to be deployed or wherever they can do the scan best from. We use Docker abstractions. You could, if you're really good with Chef, you can sort of do the same thing with normal instances. You could do it with AMIs. But we wanted to make sure that we didn't run into tool collisions in terms of dependencies. Docker also allows us to have that scalability aspect. And we called it a security automation framework because we really want to focus on the idea of it being a framework. This is a way to run tools. It is not the tool. It's not the reporting dashboard. It's just a way to be able to scale something. And we can swap in and out whatever tools we want to be able to run. We can swap out the dashboards in the front, but it's just the framework for being able to build it. And then, of course, we always went back to the question of why not cron? Like why? So that we kept ourselves on track, because this is a lot of work. It's about a year of development time to be able to build it out. And if you're going to invest that much time and that much effort into something, you want to make sure that you keep it on track with what it is that you want to be able to get out of the tool at the end of it. And so, keeping the why not cron in the back of my mind, especially when things got hard in terms of making decisions, made me make sure that I focused on what the value add would be over just doing cron jobs with Python scripts and dumping things to flat files and doing a bunch of reps and seds and knocks and all those fun things. And there have definitely been times where I was like, oh, I shouldn't have gone with that. But ultimately, we're getting to where we want to be with that. So just go ahead and sum up. Security automation covers a wide array of things. And you don't necessarily have to go with scalability. Like the advent of the cloud has gotten everybody focused on the scalability aspect. But sometimes consistency matters. When you get hacked, you're typically not being hacked over the fancy thing. You're being hacked over the thing that you forgot about and is still out there, or the special snowflake thing that was outside of your process, or very, very simple things. So just being able to establish consistency in an environment and have everything built to the same standard and then raise that standard slowly over time. There's a lot of value in that. And you can do that by using some of the existing build tools that are already out there. You can go and you can augment those any of those tools and add the scripts into them. And then if you have a small team, that's even better because you're only maintaining that small bit of code as opposed to maintaining the entire framework. And it's much easier for developers to understand what the changes you want to make to their development environment. So if they're doing continuous integration, continuous deployment, they're not going to be nervous that your tool is going to break that and they won't be able to push 20 times a day, that they'll still be able to push 20 times a day. And then I think a lot about like what the output of the tool is going to be and how that data is going to be interpreted. And are you going to be able to provide are you going to be able to provide management with the answers that they need? And that will guide them towards the things that they need to understand as a large problem, right? So you've got like the 50x SS through the 5 versus 5x C problem. How do you make sure that the data, even though the numbers are large, focuses on the things that are critical? Because that will ultimately determine whether you have value add, right? Do you want teams focused on patching bugs? So you're going to go after measuring how many times you have cross-site scripting in your environment? Or are you going to have them focus on the long-term goal and measure them against things like content security policies and HSTS, index framed options, and security headers? Because those will send teams in two different directions. And if you only got to have a couple of sprints with that team, that might be an important decision to make. Like what's more valuable if you only have like 1 or 2 sprints from a team to focus on security work? Do you want to go for the long-term stuff, or do you want to whack-a-mole to sort the existing bugs? And the bugs will come back later, and you'll deal with them again later. So really think about those things, because ultimately, if you want to get the value out of the tool, those are the things you want to focus on. Building the tools is a great engineering challenge, but it'll be a great engineering challenge no matter what you do. You want to make sure that at the end of that engineering challenge, you really have a value for it, and that you're getting the metrics, and you're getting the consistency, and you're getting the data that you want. So with that, that's the conclusion of my talk. If you want to reach out to me and talk to me about this, I am online. You can send me questions online. And how much time do we have left for? 14 minutes. We also have some time for questions if anybody has questions.